Okay, so the first thing I'm actually going to have you do, because you should have your notes open, we're going to go and reopen Rady, but I want you to do it a way where you're not going through Schoology. And some of you may know how to get there, some of you may not. But I realized at the end of last period when somebody asked me a question that not all of you have your Google Drive set up in a certain way. So for me, when I go to just like my folders on my hard drive, I have a My Drive folder, or yours may say File Stream or something like that. And I probably have a ton more things over here than y'all do. But if you can't get to it to use it like simple folders like this, then I'm going to show you how to do that. Because the online version of the Google Drive, I can't always get it to cooperate with me like I think it should work. And I like it better this way. But so if I go to my drive online, okay, then I can still get what I need, and your folder should be at the top and you can still find what you need. But I'm going to show you what you can do to get it actually on your computer if it's not already there, because it's simple, and then we'll pull up what I want you to pull up. But when you're in your drive, this little settings thing, if you click on this and then choose Get Drive for Desktop, and then most likely you don't have the old version, so I wouldn't worry about that. But then download and install Drive File Stream, and then download for Windows. So I'm not going to actually do it because I already have it. And then it'll download it, and then you can run it. And since it's going to sync everything, it might take a little while. But then eventually, down at the bottom right, where you have the little icons of things running, you'll have a little Google Drive, and it'll pop up. It'll open, every time you start your computer. The nice thing is, if you don't have internet, you can still get to some of your Google Drive stuff. And if you do that and the internet poops out, then whenever you get back on, it's going to sync together. So in my drive, you see the little, you see the little clouds. That means most of that is probably in the cloud, but so you can download it to your hard drive. So either way, whether you're here or whether you're on your online Google Drive, you should have a couple of CAMI folders, right? You probably have the same three I do: the CAMI assignments, CAMI Schoology, and CAMI uploads. Anything you open in Schoology and CAMI will end up in this CAMI Schoology assignment. So I'll open mine, and I know you have a bazillion more than I do because you open multiple things, at least for me, in CAMI almost every single day. You can sort them, so like if you want the latest on the top, just click on your date modified, and that's what I can't always get to cooperate online, but so you can find things easily. What I want you to get, which should be in your CAMI Schoology assignments, but for me it's not, because that's not how I opened it. Mine's in my uploads. So if you do anything where you use the little blue K and that's how you open something, then it ends up in your CAMI uploads. But I want you to find your Rady digital foldable that you did yesterday. Okay? So since we're opening it this way, it's not opening a CAMI file, it's opening the PDF. So if you still wanted to annotate on top of it and write on it, you can't do it from here, most likely, or at least not the same way. So if you still needed to edit it, then you would still want to open it in CAMI. But just wanted to get us here so we can talk through this real quick. All right. So get it opened, however, you can always download the file later, like the file stream later. And if you're having issues with that, let me know and I can help you with that. But so I'm going to talk you through this because I do want you to have this open. I want you to know how to get back to your notes. The whole purpose of taking notes is so that you have something to refer to. I know that's foreign to some of you, but that's kind of the point. And in the end, I'm going to have you organize some things so you basically have a digital notebook. Because if we had an ISN, it would be like your little math Bible, which we're not going to have, but you'll still have everything here that you very well may be referring back to. Okay, when you go to do your summer assignment for calculus or whatever, you're going to need to refer back to some of this stuff and you'll know how to find it. All right, so this PPD and the links still work here. So let's talk about this. So we do have, if we have a parent function, which like I said, we're not going to deal with this that much. We'll look at one today that actually has a parent, but most of what we do won't even have a parent function, but that's kind of part of this whole thing. Point discontinuity, we know how to do. We know how to find that. We know how to find our holes, right? So we can move on to R. R are our roots, which are the x-intercepts, which are the zeros, and we have to find them after reducing. You have to get rid of the hole first. And if you're just finding what you need to find to be able to graph, you can do it in whatever form you want. But remember, if you're filling in blanks, pay attention to whether it's asking you for the roots or the x-intercepts so you know if it needs to be an ordered pair or not. Okay, and then the A It's asymptotes. It's our vertical asymptotes. And remember, it has to be unique. So again, it has to happen after we reduce. We got to get rid of the holes. And they're always lines, so we got to make sure that we actually name them as lines. And they're the zeros of the denominator. T is the tangency and togetherness. The tangency is not a brand new concept because we talked about it with our polynomials. Togetherness probably is, but we're just looking for even exponents in the denominator or in the numerator. And then we'll look at some togetherness. I don't think it actually comes up today, but tomorrow for sure. And then E is for your end behavior. So your horizontal and slant asymptotes are your end behavior. Got to keep these three things straight because it's simple if you know which is which. And remember, if you don't have a horizontal asymptote, it opens the door for a slant asymptote, but it doesn't guarantee you that you have one. And then we divide. And then Y is a y-intercept, which we can totally handle. So sometimes we have things like little blanks listed out. Find this, 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 and this to help you graph. If not, you can write this acronym up at the top and then make sure you have all the pieces that you need. Okay? Any questions at all? Did I impress you with my links? The answer is yes. It was very impressive, right? Okay, thank you. It took me way longer than it should have, but now that I've figured it out, I think I can handle that for some other things. All right, so let's look at what we're going to graph today. So you can keep that open in case you need to refer to it. We're going to graph, and so this has the radii written out for you. But again, if it didn't, we could just write that at the top and make sure that we find all of our stuff. So the first thing that we need to do is we need to factor. So f of x is equal to, we get x plus 2 up here, and down here, we get x, and the signs are opposite, so I have a positive 2 and a negative 3. All right, so does this function here have a hole? Yes, because there's something I can cancel out, right? So I'm going to cancel this out. That means the x value for the hole is at negative 2. I'll figure out the y value in just a minute. My reduced function is f of x equals 1 over x minus 3. Okay, so this is now the function that I focus on. It is a parent function of, it has a parent function, the reciprocal function, and we could do that with some translations, but we're going to go ahead and run through the rest of this stuff, because now since you know it's a reciprocal, you know what the shape should look like, and it should just kind of move over, but we'll see how all the rest of this helps us figure that out, even if we didn't know that. So now I need to find f of negative 2, so that I can get my y value here. So this is going to be 1 over negative 5, so negative 1/5. Then my roots are the zeros of the numerator. So what are my roots? I don't have any, right? It's the empty set. There's nothing, because there's not even a variable up there, so it's just the empty set. My vertical asymptote is the zeros of the denominator, so I will have 1, and that's going to be x equals 3, right? And then tangency and togetherness, none of my factors have any exponents at all on them, so this is going to be none. This is bottom heavy, so do I have a horizontal asymptote? Yes, I do, and it's really simple. What is it? Y equals 0. So since I have a horizontal, I know I don't have a slant asymptote. I need to find my y-intercept, so that's f of 0, which is going to be negative 1/3. So my y-intercept is 0, negative 1/3. Okay. So I have all my blanks. We're still going to have to do the number line, so I'm going to rewrite my reduced function right here, so when I scroll I can see it. So f of x equals 1 over x minus 3. Any questions at this point? All right, so we're going to scroll. And then we need to do our number line. So on our number line goes our zeros, which we don't have any, and our asymptotes, which we have 1, and it's 3. It's an asymptote, so it's an open circle. Then I can find my sign. So if I substitute in something less than 3, like 0, I get a negative number. If I substitute in something more than 3, like 4, I get a positive number. So this is negative, this is positive. Okay. So then I'm going to go through and just plot everything I know so far. So instead of me scrolling up and down, I'm going to look at my paper where I have it written. So I have a hole at -2, -1/5. So I'm going to go to -2, -1/5. That's where I have a hole. I don't have any roots because it's the empty set. I have a vertical asymptote at x equals 3. So here's that. I don't have any tangency and togetherness. I have a horizontal asymptote at y equals 0. And I have a y-intercept at 0, -1/3. Okay, so that's everything I've got. Now, I know from my sign chart that I go from -infinity to 3, and it's negative the whole time. So even though it's possible to cross a horizontal asymptote, I know I'm not crossing this one because I don't get to cross the x-axis. So it stays negative the whole time, so it's going to have to come in something like that. So I'm just going to draw this in. I do not draw straight through the hole because it's a hole, and then it's going to have to look like that. Right. So again, it says this is a parent function. I know that the other curve is going to have to come like this. The other reason I knew that, even if I didn't know my parent functions, is that from 3 to infinity, it's positive the whole time. So I know it's going to have to hug this asymptote and stay positive. It'll never cross that horizontal axis. But I don't get to just sketch in that curve because I need something to tell me how close it gets in different places. Like it probably would have been even been a good idea for me to get a point right here. So I'm going to grab a point over here and see what happens. We'll use 4. Sometimes we have to check a few points with by substituting them in. So we'll use 4 for x. If I use 4 for x, I'm going to get 1 for y. So I can plot that point for 1. So I know how close it actually gets, and I think that's good enough to be able to sketch this in. And there is my graph. What questions do you have? Anything? Good. All right, let's check number 2. So the first thing I'm going to do is factor. So be positive and negative, so I'll have a -2 and a +1, and then x minus 2 in the denominator. So do I have a hole in this function? Yes, I do, because I can cancel these out. So my x value is 2. My reduced function is f of x equals x plus 1. And what will that part graph? A line. So I'm going to have a line with a hole in it. So again, I kind of have an idea of what it looks like. I find f of 2 to get my y value here. So that's just 3. So that's where the hole is. My roots come from the zeros of the numerator, which is x plus 1. So that means I have a -1 for a root. There is no denominator, so I don't have any vertical asymptotes. There's nothing with any exponents, so no tangency or togetherness. Horizontal asymptote, well, it's top heavy, so the answer is no, or none, I'm sorry. And then the slant asymptote, since it's a line, we're going with none. My y-intercept is f of 0, so that's 1. We get 0, 1. Now, even though we know this is a line and we know how to graph a line, we're still going to do the number line and kind of talk through how all of this tells us that even if we didn't know it was a line. So I'm going to rewrite this. F of x is equal to x plus 1. Okay. Any questions at this point? All right. So My number line then, the only thing I put on there are my zeros, so -1. This is closed. And so if I substitute in a -2, it's going to give me negative overall. If I substitute in 0, it's going to give me positive. This is negative and positive. And then let's plot what we know. We have a hole at 2, 3. There's my hole. Have a root at -1. I have no asymptotes or tendency or togetherness, but I have a y-intercept at 0, 1. Okay. So from -infinity to -1, my function's negative. Well, that makes sense. It's coming up like this, right? And then from -1 to infinity, it's positive. So if that stuff didn't match, something would be wrong. And then we can just draw in our line, and you can use your line tool because I'm gonna cheat here too. Remember, don't draw right through the hole because it's a hole. And that is what our graph looks like. Okay, any questions at all? Alrighty, then let's look at the last one. I'm going to factor. So f of x equals, so I'm going to have to factor the numerator, get x, positive and negative, so +4, -3, x and x, I have a +2 and a -3. So do I have a hole in this function? Yes, I do. You will not have a hole in every single function, just happens to be on these, so that cancels out. So I get f of x equals x + 4 over x + 2. This is not something that has a parent function. So at this point right now, you don't really have any clue what it looks like. But that's okay, because all the rest of this stuff is going to help us. So I'm going to start by finding f of 3, so I can get my y value for the hole. And that's going to give me 7 over 5. It's a +7/5. My roots, I'm just going to have 1. They're my zeros of the the zeros of the numerator. So I get -4. Vertical asymptotes, zeros of the denominator, so x equals -2. No factors have any exponents, so there's no tangency or togetherness. Do I have a horizontal asymptote? I do, right? Because they're tied in degrees, so that means it is y equals what? 1. Good. Since it's tied, I have the ratio of the leading coefficients. If I have a horizontal asymptote, no way I can have a slant asymptote. Y-intercept is f of 0. So that's going to be 4 over 2, which is 2. And then I'm going to rewrite my function. X equals x + 4 over x + 2. Any questions at this point at all? We're all good? Okay, so let's do our number line then. Get our signs, or our sign chart rather. So I put 2 things on here. I put my zeros and I put my asymptotes. So I'm going to have a -4 and a -2. The -4 is closed, the -2 is open. So if I substitute in a -5, that's going to give me negative over negative, which is positive overall. If I substitute in a -3, that's going to give me positive over negative, that's negative overall. If I substitute in 0, it's positive, positive, positive overall. So positive, negative, positive. So now that I have all of that, I'm going to go and plot everything I have figured out. So I know I have a hole at 3 7/5. So 7/5 is like 1 2/5. So 3 1 2/5 is about right there. There's a hole. I have a 0 at -4. I have a vertical asymptote at -2. I have a horizontal asymptote at y equals 1. And I have a y-intercept at 0, 2. Okay. So, with all that, see what we've got here. I've got from -infinity to -4, it's positive, right? So I know it's positive this whole time until I hit here, so it's going to come down. What none of this information so far tells me is whether or not I cross that horizontal asymptote. Okay, so we would have to check something else. I'm just going to tell you on this one that it doesn't, and then tomorrow we'll talk about how we really figure it out. So you just can take my word for it on this one. So it stays positive, but underneath the asymptote until it gets to this point. And then from -4 to -2, it's negative. Now, even if I didn't have my sign chart, if I knew that much, then I know I don't have any tangency or togetherness, so I know the function isn't going to be on this side of the asymptote right here. It's going to have to be up here. Well, it's going to be up here. It's going to cross through this point, and then it's going to be positive from -2 to infinity. Again, that doesn't tell me whether or not it dips down and then comes back up, but I'm going to tell you right now that this one doesn't, and then we'll look at some that do. So this comes down like so. I don't draw through the hole. It looks like this. So it still has the same basic shape as the reciprocal, but that's not always going to happen either. Okay? And I didn't have to find any extra points on this because those were enough to let me know kind of how close I got and what my shape was. Any questions at all? We're all good? Awesome.